I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
As humanity races toward a new space age, with rockets launching almost every week, there's a growing realization that our journey to the stars comes with an environmental cost. Traditional rocket fuels, while powerful, release tons of carbon dioxide, black carbon, and harmful chemicals directly into our atmosphere, often into layers where they linger for years. But can we explore space without polluting our skies? That's exactly what scientists and engineers around the world are working on today, creating eco-friendly rocket fuels that can power our ambitions while protecting our planet. Every rocket launch is a marvel of engineering, but it's also a burst of emissions. The Falcon 9, for example, burns roughly 400 metric tons of RP1, a highly refined kerosene combined with liquid oxygen. The exhaust includes carbon dioxide, soot, and water vapor, all injected high above the clouds where their impact on climate and ozone can be significant. Hydrazine, another common satellite fuel, is so toxic it requires special handling suits. Solid rocket boosters release aluminum oxide and hydrochloric acid, substances known to damage the ozone layer. And with thousands of launches projected each year by the 2030s, the pollution problem can no longer be ignored. The challenge is clear. How do we keep exploring the universe without harming the one world that sustains us? To answer that, researchers have been reimagining rocket chemistry from the ground up, and the results are inspiring. New green monopropellants like AF315E and LMP103S are safer alternatives to hydrazine, less toxic, easier to store, and, in many cases, even more efficient. NASA and the European Space Agency have already tested them successfully in orbit. Another cleaner option is liquid hydrogen combined with liquid oxygen. When they burn, the only exhaust is pure water vapor, one of the cleanest reactions known to science. This was the same fuel that powered NASA's shuttle program and still powers heavy-lift rockets today. The only drawback is that liquid hydrogen must be stored at an incredibly low temperature, around minus 253 degrees Celsius, making it a challenge for storage and handling. A major breakthrough now taking center stage is methane-based propulsion. Rockets like SpaceX's Starship and Blue Origin's New Glenn are powered by engines that burn methane and liquid oxygen, a cleaner, more balanced solution. Methane burns with fewer particulates and less soot, helping engines last longer and remain reusable. Even more exciting, methane can be synthesized using captured atmospheric carbon, potentially making future launches carbon neutral. SpaceX even plans to produce methane on Mars using local resources, creating a closed-loop system that supports sustainable interplanetary missions. But innovation doesn't stop there. Scientists are experimenting with rocket fuels derived from biological sources, such as algae. The U.S. Naval Research Laboratory has already demonstrated small rockets powered by these bio-derived propellants. They're renewable, sustainable, and could one day make space travel as green as it is groundbreaking. Meanwhile, new types of propulsion are redefining how we move in space. Electric and ion thrusters use electricity, often generated from solar panels, to accelerate ions of gases like xenon to extremely high speeds. They consume only small amounts of fuel but can sustain thrust for months or years. NASA's Dawn spacecraft, for instance, traveled billions of kilometers using just a few hundred kilograms of xenon. Then there's the elegant concept of solar sails, spacecraft propelled purely by sunlight. These giant reflective sails harness the pressure of photons, allowing ships to glide silently through space without fuel or emissions. Missions like the Planetary Society's LightSail 2 and NASA's upcoming solar cruiser are proving that this once science fiction idea is becoming reality. Europe and Poland have also become leaders in developing green propulsion. The European Space Agency's Prometheus engine is reusable, methane-based, and designed for low-cost, sustainable access to space. In Poland, a major milestone came in 2024 with the ILR-33 BURSZTYN 2K rocket developed by the Łukasiewicz Institute of Aviation. This rocket used 98% pure hydrogen-peroxide as an oxidizer, producing only oxygen and water vapor as exhaust. It's a stunning demonstration that clean rocket propulsion is not just theory, but reality. At the same time, projects like Germany's DLR and the University of Stuttgart's Hydrogen-Ind initiative are pushing forward with green hydrogen. Hydrogen produced entirely from renewable energy. This means rockets can launch using hydrogen made from water with zero carbon emissions. If scaled successfully, this technology could form the foundation for Europe's carbon-neutral launch goals by 2030. Of course, the transition to green fuels isn't without challenges. Some eco-fuels have lower energy density, producing less thrust per kilogram. Others require new safety systems, infrastructure, or cryogenic storage that can be costly. And scaling up green hydrogen or biofuel production will demand time and investment. But these are engineering problems, and solving engineering problems is something humanity has always excelled at. Imagine a future where launch pads run on renewable power, where reusable rockets fly dozens of times, fueled by carbon-neutral methane or green hydrogen, where solar sails and ion thrusters carry our explorers silently across the solar system. That's the world being built today, one where sustainability and exploration go hand in hand. Because the journey to the stars should never come at the expense of the world beneath our feet. We are witnessing the dawn of a truly sustainable space age, a future where every rocket launch brings us closer not just to the cosmos, but also to a cleaner, more responsible Earth. This is the future of space, clean, green, and full of promise. To learn more about the technologies shaping tomorrow, subscribe to the IDST channel and read the full article at idsteach.com. Thanks for watching. Subscribe, follow, or visit IDSTH.com for more cutting-edge defense and tech insights. See you in the next one.